Okay, this is from problem set 5. It's number 1. We have a clothing business finds there's a linear relationship. Okay, so linear, so that automatically tells me right there that my equation will look something like this. Now we might be using different variables and stuff, but it's going to have that look to it. The number of shirts N and the price it sells P. Okay, so those two pieces, it relates the number of shirts and the price. So those are going to be my two variables. N will be the number of shirts. Well, I'm striking that out. I don't know. I meant to just change the color here. So those are my two variables, N and P. Then it goes on to says from a historical perspective, blah, blah, blah. Shows that 1,000 shirts can be sold as $30 a piece. That gives me a ordered pair because 1,000 shirts is related to the price $30. And then the second one, it goes on to give me 3,000 is related to the $10. So that's 3,000 comma 10 for that ordered pair. And I just need to write the equation of that line, right? So that means I need to find the slope first. So y minus y1 over x2 minus x1. So the slope is going to be a negative 1 over 100. And I'm going to start off with slope-intercept form. Now remember, I always wrote it like this before. But, you know, we do have different variables here. So let me just call it P minus P1, slope, N minus N1. Just to make it kind of to match, right? Okay. So P1 is 30, negative 1 over 100. Times, and then N minus N1 is 1,000. Now, since we wanted P of N equals, I'm going to solve for P. So I'm going to distribute through the negative 1 over 100 here to both of those. That's going to be plus, and then 1,000 over 100 is going to be 10. Now we're going to add 30 to both sides. And that's going to leave us with P is negative 1 over 100 plus 40. So in function notation then, we're just going to write that as P of N. And that is going to be the equation that represents that particular situation. Okay, now number 2 was another word problem. A farmer finds there's a linear relationship between the number of beanstalks, N, and the yield, Y. Okay, and it's a linear relationship, so we're going to have a Y in N. Okay. So let's see, when she plants 30 stalks, each yields 34 ounces. So that's the ordered pair 30, 34. When she plants 33, produces 33 ounces. Again, let's find the slope. So we're going to have y minus y1, 34 minus 33 over 30 minus 33. So that's going to be a negative 1/3 for our slope. So again, y minus y1, so y minus 34 equals negative 1/3, and we have n's instead of x's. So n minus 30. So y minus 34, negative 1/3 n plus 10, because again, we're going to distribute the 1/3 there. And now I'm going to add the 34 to both sides. So we're going to have negative 1/3 plus 44. And the last one, I think, was number 7. So it has an absolute value. And we want to find the x and y intercepts. Now remember, if I think about the graph of this thing, and I'm not going to draw the graph accurately here, okay? But I do know just from some of our transformation stuff, we can shift the graph to up 9, we reflect it, we stretch it, we go left 1. So the graph is just going to be an upside down V, you know, I don't know, something. But remember, the x-intercepts are these 2 points where it's crossing the x-axis, right? So those are my x-intercepts. Wherever it crosses here is the y-intercept. Now we know the y-intercept is the point 0 something, and x-intercepts are the point something 0. All right, so let's go ahead and find the y-intercept first, because this tells me to substitute x or 0 in for x. So to find the y-intercept, we know we have the point 0 something. So we just want to find f of 0. That's negative 3 times the absolute value of z plus 1 plus 9. So that's negative 3 times the absolute value of 1 plus 9. Now the absolute value of 1 is just 1. So that looks like it's going to wind up being 6. So the y-intercept is at the point 0, 6. Now for the x-intercepts, we know the y-coordinate is going to be 0. So I know I'm going to have the point something 0, and it looks like I'm going to wind up having 2 of those. So I'm just going to write them both up here to start with. And we know y is 0, so 0 equals negative 3 times x plus 1, the absolute value of. It's 9. Now when I'm solving the absolute value equations, remember we've got to get the absolute value by itself first. So I'm going to add 9 to both sides to start with. And that's going to give me 9 equals negative 3 times the absolute value of x plus 1. Now I'm going to divide by negative 3. And that's going to give me a negative 3. Oh, I messed up. I needed to subtract 9. Okay, so this is the advantage of having an ugly sketch that's, you know, at least somewhat in the right shape and stuff, is I knew it had 2 intercepts, and when I got to this point and had a negative 3, that wouldn't have any solutions. So that would have no intercepts. So that tells me, oh, I've screwed something up. Let me go back and look. That should have been a negative 9 there, and that would be a positive 3. So little things like that can help you catch the sign errors and stuff like that, okay? Now I split the absolute value up, and x plus 1 equals 3, or x plus 1 equals negative 3. So when I subtract 1 from both sides here, we get 2. In this one, I'm going to get negative 4. So my 2 x-intercepts are 2, 0, and negative 4, 0. But I always think about the graphs when I go to solve these things, because I'm really bad at times for making goofy little mistakes just like anybody else. And if I know how many answers I'm looking for, sometimes that will help me catch it. All right, so I hope this helps, and have a great evening.